We'll get to this little piece of hardware in a few minutes, but let's start with setting the stage. I'm going to be talking about user InterSystems IRIS and IRIS for Health with IoT, Internet of Things, all sorts of devices. I have two kinds of devices actually today that I'm going to connect to. One is I'm wearing on my wrist. It's a Fitbit. Like it collects my heart rate and how much do I sleep, how much do I walk and so on an ongoing basis, right? I'll be pulling data from that thing, right, into my IRIS application. Another thing that you've seen on the screen is a little sensor that would let me to collect my heart rate in real time right here. If you look at the Fitbit and maybe you have your Apple Watch, you see this little green light, sometimes it's a blue light or a red light. It's the same sensor that you'll find here is in that little device. It's just totally exposed, and I can do absolutely everything with it. Right? So we're kind of covering the whole spectrum of things that can connect to human being. From high-level consumer-friendly devices like Apple Watches and Fitbit sensors to really low-level sensors that possibly the lowest possible point of contact between you and the data that is supplied by the device. But let's start by setting the stage and talking about what IRIS for Health is and what IoT is. There are multiple ways of explaining what IRIS for Health is. I just like to explain it from historical perspective. You probably know that InterSystems is not a single product company. We do have electronic health record system which is used all over the world called TREC. It's laboratory system, it's electronic medical record system. By having this system in our portfolio, not only we did a lot of development and created comprehensive data model that contains everything that electronic medical record need to capture about the patient, but we also got practical experience in the field. From our implementations all over the world, we know what people in the field expect from their IT system. Right, so all of that, a lot of this experience we can reuse and repackage and at the end of the day use it in our IRIS for Health. Another area, another product that InterSystems has is called Health Information Exchange. You can picture countrywide or statewide system that connects all the possible points of services, hospitals, ambulatories, lab systems, collects data, aggregates data from all of these systems, and provide you comprehensive, unified view of the patient data. So basically, everything that happens with the patient through the continuum of care is being aggregated by Health Information Exchange, InterSystems Health Share, right, and being represented in a patient-centric or population-centric model for the analysis. Side effects of that, to do that, we have to connect to every known system out there. We have to support all the protocols. We have to support all the standards. We're regulars in connectathons. We certifying and verifying that InterSystem technology works out of the box with any healthcare standard that's out there. We started to work on implementation of FHIR before FHIR even became the thing. Right? We constantly updating our implementations of standards and protocols and let them available to make them available to you in IRIS for Health. And again, it's not a secret. We're also a database company, data platform company, and again, you can look at different metrics and different research, but probably up to 60–65% of U.S. population alone has their electronic health record in InterSystems database. Like, thanks to the partner like Epic, thanks to the customers like VA, right? To build this kind of system, we have to have enterprise scale security, reliability, availability, and so on and so forth, right? And in essence, InterSystems IRIS for Health is a combination of things that we develop over the years and continue developing just to deliver these products packaged together as your healthcare integration platform, right, or healthcare application development platform. So you can think of IRIS for Health as interoperability platform with a whole bunch of industry agnostic and industry specific standards and protocols, with both FHIR and our own SDA data model that can store and process all the possible healthcare data you can capture about the patient, and enterprise level security, reliability, availability, and so on and so forth. Right? Let's switch to IoT. Again, there are multiple ways of describing what IoT is. Let's pick one and talk about reference architecture. That's a typical reference architecture for typical IoT systems. On one hand, you have your devices or things. Right? And these things, one way or another, they connected through internet to your backend or your hub. Right? If device is capable of communicating through TCP/IP, it usually directly connects to the hub and to the backend for that. Sometimes devices don't have TCP/IP connectivity out of the box. This Fitbit, it doesn't have TCP/IP. It uses my phone as a hub to connect to the cloud where this data is essentially stored. So one way or another, data travels to the cloud, to the hub, to the backend through TCP/IP, but you might or might not need a gateway to enable this. But at the end of the day, you have a device that is connected one way or another to the cloud, to the hub, to the backend, right? And this component that you might need to use to TCP/IP enable this device, if you can use this term, is called gateway. Then you have a hub. In Internet of Things, the typical implementation of hub is based on MQTT protocol. We'll talk about that protocol in a few slides. But again, it's very standard, well-known, and if you do an IoT protocol, most likely you'll need implementation of MQTT protocol in one form or another, right? And you have a hub or a broker that let your devices to communicate to the backend and backend devices to communicate with devices, right? This is typically MQTT platform. Backend can be anything, right? It can be cloud-based solution, it can be IRIS, it can be whatever. I don't know how exactly, where exactly Fitbit stores this data, right? It's probably some server somewhere in the cloud. What I know, this backend lets me to connect to this data from my analytical platform, from my application, from my UI, and so on and so forth, right? In case of Fitbit, my phone is not only the gateway that lets data from the Fitbit to get to the cloud, but it's also an app that let me as a user to consume the information, right? It's an analytical tool, if you will, right, that shows me my sleep cycles and so on and so forth, right? So, but whatever IoT systems you build in, you'll typically find these moving parts in there, right? Again, the protocol that's typically here is MQTT. This is MQTT hub or MQTT broker, right? They're MPQ. If you'll talk to Microsoft guys, they say Azure is superior to all the other cloud providers just because they do not MQTT, but AMPQ by default, but they also support MQTT. Right, but anyways, typical protocols you'll find there is MQTT. Speaking of devices that can touch your body, right, again, there are a whole spectrum of devices. On one end, there are consumer-friendly devices like this Fitbit, like your Apple Watch, very easy to use. Again, the idea is to make it as convenient for you as the user as possible. Use that. On the other end of the spectrum, you have sensors, like thing that captures the readings from your body right? And what you're doing with these readings is absolutely up to your application, up to your solution, right? And obviously, totally different development paradigm, totally different development style if you're doing. In the middle, you have something you'll find in a hospital, right? The biggest contributor to the price tag, so to speak, is FDA approval. If you're in United States, FDA. If it's in Canada, it's Canada Health that put the stamp of approval that, yes, this thing can touch your body, and you can get the readings from this thing and use it in making clinical decisions, or use it to administer medications or anything like that, right? You can find some anecdotal numbers that, for instance, certify one of the devices, get FDA approval for one of the devices can cost you $30, $40 million. Just the process itself, let alone the development and production of the actual device, right? So it's a very expensive process, and not that many devices you would find in this area, devices that are approved for use in medical care, and a whole bunch of different protocols. So let's concentrate on the two ends of the spectrums. We wouldn't talk about this that much, right? So let's start with consumer products. Right? I picked 3 here. There are way more, right? There are a whole bunch of like new generation of gyms that first thing they do, they strap the heart rate sensor to your chest and like showing you all sorts of the graph, how much calories, how much fat you're burning, and so on. I'm getting kicked off out of all of this because my rest heart rate is pretty high for some reason, right? But there should be a protocol with which you can read data from this device, or from the hubs, or from the cloud, and there should be some way of authenticating your application, your IRIS-based application, or whatever your development platform is, to this platform, to these devices, to these databases. Fitbit apparently is easiest to use from developer perspective, right? They use a REST protocol for interfacing, and they use OAuth 2.0 protocol for authentication, right? We'll talk about that again in a second. Right, but that's something for both. We do have support out of the box. Getting into details of that, it's a topic for the whole separate sessions. We're not going to go there. Just trust me, we do have everything you need, including very nice series of articles on how exactly you do that. That is published in our InterSystems community. Apple is doing everything Apple's way. If you want to get data from Apple Watch as a developer, you have to work with Apple Health Kit. You have to do development in Swift. You have to write application the way Apple envisioned it, right? They do have authentication procedure which is similar in concept to OAuth, right? But it's totally proprietary to Epic, right? Garmin. I've tried to get Garmin to work, and they have some convoluted system just to get access to their API. Fitbit, I just get to my Fitbit portal. I did a few clicks, and here we go. I have endpoint and the authentication key to get access at least to my data, right? With Fitbit, please sign this paper. Please certify that you're working for that company, and how much Garmin hardware you're planning to buy. Sounds familiar, right? We changing, by the way. But I abandoned this effort to connect to Garmin. But from what I understood from their documentation that's available, it's REST and older version of OAuth protocol. Right? So if you are planning to develop your application with these kind of devices in mind, your place in the IoT ecosystem would be here. You would be one of the apps connecting to the back end that is managed by Fitbit, by Apple, by some other device manufacturer. Okay? OAuth. Again, we're not spending too much time to that, but you've probably seen this kind of screen many times in the past few years, right? Then you're trying to log into some website and say, I don't really want you to create yet another password, but I would let you to use your password that you have in some other OAuth provider, right? That's the whole idea of OAuth, right? You have trusted third-party entity that can certify that you is who you are. And you, as a human being, have to go to the website, and this website, like Fitbit website in my case, would say, hey, do you want to authenticate with Facebook or with Google? I say, Google. Okay, it switches me to the Google. Google knows my credentials from my cookies or whatever, right? And asks me a couple of questions. Do you really want to trust your information to Fitbit? Yes, I am, and off I go. I'm not creating a new password, new identity just for the Fitbit. Same idea here, right? A whole bunch of OAuth providers out there. Fitbit, Garmin would be one of them, right? But the workflow is you should involve the person who owns the device or the account, right? It should be logged into his or her device or account, and at some point they should say approve, right? The same way as this website asks me to trust the, let's say, Facebook credentials, right? If I'm creating my own website, my own website would be asking these kind of questions, right? And it would be asking Fitbit to verify. So in my application, Fitbit would be one of the options here, or only option if I'm working with Fitbit, right? Again, there is great three-part series at InterSystems community that covers every single step that you need to do to connect to OAuth-enabled system with InterSystems IRIS, right? There's samples and there's documentation, and obviously we do support that out of the box in IRIS. FDA-approved devices, again, variety of ways, a lot of things to talk, and it's really device-specific. Right? Device-specific, manufacturer-specific. There is no really well-established standard there if you want to connect it to one of the applications there. Right? And you most likely be connecting to one form of gateway or another. Right? Then I did my heart check. They put me on the Hotler monitor. So for 2 days I was wearing this whole bunch of sensors with the device attached to me. And then I suppose if I want to get a hold of this data, I need to bring my computer next to their computer. Some very convoluted scheme that I don't know exactly how it works, but again, be ready that it's very specific to the particular device, particular provider. Sensors, the most interesting, the most exciting for me as an engineer. A sensor, again, this thing, right? You've seen it on a screen before. Very tiny, very simple device. The protocol that you need to support to talk to these sensors is GPIO, General Purpose Input-Output. If you ever heard of Raspberry Pi or Arduino platform, they do support that out of the box. GPIO is nothing but, hey, do I have signal on this pin or not? Is it above 5 volt or is it below 1? Is it 1 or 0? Like they're digital GPIOs and they're analog GPIOs. Like very simple, very primitive, right? And you have to have specialized hardware that can read these kind of signals. Let me switch for a second. Okay, here we go. So this sensor, again, the same sensor as you have in Fitbit, right? This sensor has 4 pins. I can connect to 2 of them I used for power, my ground and 5 volt, and 2 are these GPIO sensors, GPIO pins, right? It has some very primitive chip on board that can translate the raw readings, right? The sensor itself is nothing but light emitting diode and a photosensor, right? That measures how much light passes through your finger, right? But somehow, based on that information, they detect your oxygen saturation and heart rate, right? This thing is a controller. Controller, in this case, it's Arduino compatible ESP8266 that has these GPIO pins. It's connected to the Wi-Fi, right? And it has a whole bunch of libraries that would let you to implement whatever you need to implement relatively easy. Let's switch back to, this is first few lines of my code for that controller. Right, as you can see, I have library for Arduino framework. I have library for Wi-Fi chip that is embedded in this controller. I have library for PubSub client, which is MQTT client for Arduino, right? And then I have specific library for that particular sensor, right? So if you think you need to decode like really how much light travels through my finger, not really. Most of these sensors, they do have out of the box libraries that give you high-level readings. So amount of code you need to write for this kind of thing is not that big, right? So, but the most important part, if you work with sensor on a low level, you need the controller board that is capable of doing GPIO. Like the well-known boards are Raspberry Pi and Arduino. Your computer doesn't have it. Well, it probably does, but I wouldn't go into my MacBook and try to figure out where it is. Like, it definitely would void warranty and probably would compromise the entire thing. Now, MQTT. MQTT became the de facto standard for Internet of Things. The origins of MQTT protocol are, it's 20 years old, and it was designed to monitor sensors attached to the pipeline in the middle of the desert, right? They don't have Wi-Fi in the desert. The only option to send this data to the hub was satellite communication. They don't have electricity there, so they have to be operated on a battery. So this protocol is very battery efficient. It's very communication efficient. Like the shortest valid message in MQTT protocol is just 2 bytes. Right? And it's very bandwidth efficient, right? And it's reliable in terms of if something doesn't work, you can resend it, and eventually you would receive it. All right, so if you're working with a sensor, a couple of more things. The well-known implementation of MQTT, you need a client and you need broker. Right, for brokers, well-known implementations are open source Mosquito and RabbitMQ. And all the cloud providers, I'm listing here major 3, they based their IoT hubs on MQTT protocol. If you look at AWS and Google Cloud, that's just MQTT. They have elevated security. The problem with this kind of device, sometimes the device memory is so small that authentication key for Amazon, for instance, would not fit in the memory of this device. So you have to go up to a certain level of devices just because of the security requirements of AWS IoT Hub. But it doesn't change the nature of the protocol, right? They add a whole bunch of security and added services to that, but they run MQTT protocol. Azure and RabbitMQ, they're very proud that they're not MQTT-centric, they are AMPQ-centric, but they do support MQTT too. So again, my recommendation would be just go MQTT and you would have everything you need for IoT out of the box, AMPQ. If you're a Microsoft person, like maybe you can look at that. Clients. Actually, when I was working on this slide, I was expecting to see, again, variety of well-known open source or commercial clients out there. No. Eclipse Paho, project that does open source clients for variety of systems protocol, pretty much dominating this open source market. There's nothing out there that is reasonable alternative to Eclipse Paho. The only widely used client that I was able to find is Arduino, because Paho just doesn't exist for this kind of boards. Right? For all the other boards, Eclipse Paho is your to-go client for MQTT interaction. So, and if you look at the reference architecture in here, right, IRIS would be your backend, and you'll be working with MQTT protocol, right? We go in MQTT from the thing to the hub, but the same MQTT would work between the hub and the backend. Different authentication maybe, but still the protocol would be the same. Right? So MQTT support in IRIS. In 2020.1, we will be releasing our native support for MQTT, which is based, surprise, surprise, on Eclipse Paho. We just built in the C++ library that you would find in the bin directory down the road, plus a whole bunch of service classes around it. Today, you can use either Java Business Host based on Eclipse Paho. Again, this is the GitHub link. Or, again, there's open source implementation of MQTT protocol entirely written in cache script, or object script. Right? So if you want to do IoT projects today, nothing stops you. Now, let's go to the demo. Right? I'll have extended version of the demo that contains interface to your phone and sending SMS messages and so on, but I'll show you today just the IoT part. Right? IoT part will connect to the Fitbit, this thing, right, through REST. Right? And that would give me things like my rest heart rate, my statistics in terms of in what zone, in terms of resting zone, for fat burn zone, or high activity zone I am during the day. Right? And if I want to check my heart rate right now, right this second, I'm going to this controller board and the sensor and getting the same information through MQTT protocol. So within the same application, we collect in the same information, the heart rate related information, two different ways. So let's do that. So I have a little demo application, InterSystems wellness application. Let's say we have a wellness clinic and we get a patient, right? As soon as we start appointment with John Smith in this case, right, let's see what happens. Right? So you can see by the trace in here that actual REST request with Auth 2.0 authentication token went to the Fitbit server, and I get the result. My resting heart rate is, again, elevated. Any doctors here? No judgment, please. But I don't have my up-to-date heart rate at this point. Right? So to get this, I'm going to the different camera. Here we go. So let me start by just uploading the new version of firmware to this controller, right? And as you can see, the code is fairly short because there are a whole bunch of libraries that I can use, right? And I don't need to recode all the things that have been done for me. Right, so let me upload this thing, and in a few seconds we would see lights blinking on the controller. Right, there are a couple of lights, and one of them right there means like firmware is being uploaded to the device. 100%, and here we go. Like the device started to boot, it connects to the Wi-Fi, connects to MQTT broker, and finally it gets the reading from the sensor is connected. So if I'll put my finger on the sensor, it took about 10 beats for readings to stabilize. Right, and again, too much coffee today. But this message should be going to the Mosquito broker that is running on my laptop right now. Right, if we'll go to the production configuration and go to messages, okay, I would see the message that goes and message that goes from the MQTT connector, MQTT adapter, right? And we send it in two ways. One way we send it is we package it as a FHIR message and send it as a FHIR vitals observation. So somewhere in here you would see my heart rate, right? And yeah, the same message is being pushed back to the MQTT broker. If we'll go back to our messages, it's somewhere in here. That you would see message from that goes to Fitbit. So we're asking data for user with this ID, and here's what we're getting back. And if we'll go back to our test wellness application, right, we do see that, again, we don't resend the message to Fitbit, but we take in the last reading we get from the sensor, right? If you look at the production configuration here, right, what I have is the single router that takes data from MQTT, right, and the same message goes to MQTT out, so basically pass through. Maybe someone else would want to do some post-processing for this, but I'm sending that to a different topic in MQTT, and I'm sending this for down processing to some health information exchange in this case. Right, if you look at the settings, for any of these MQTT specific connections, what we have here is what's your MQTT broker, what's your MQTT topic. So to what topic you publish in your messages. And again, MQTT protocol is publish subscribe protocol, and you publish message to the topic. If I'm subscribed to this topic, I would get this result and would be able to act on that. Right? Multiple clients can be subscribed to the same topic. So if I have multiple clients receiving this message, all of them would know what my heart rate right now is. So let's get back to the presentation. And the most frequent question I get after this is, where do I get all this, right? I'm not saying that's the production quality hardware. It's all made in China. Altogether, what you see here is probably about $12, including this breadboard and the jumper wires. The controller I'm using, ESP8266. There is a newer version, ESP32, that is more powerful, but I found that the power management is more trickier. Like the controller itself would consume more power, and sometimes this thing would fail just because there is no enough power. It's all easily solvable. You just put the external power supply and you power the sensor not from the board, but from external power supply, right? But again, just for this, I already got in trouble at the airport with this, right? My name is Anton, but still, I get in trouble, but for having sensors and wires in my backpack, right? Anyway, if I'll get the power supply and so on, it would be even more. If you want to buy it, it's available at Amazon. $6 for the controller, $3 for the sensor. If you're looking for the, this is called breadboard and jumper wires, what you're looking for is Arduino sensor kit, right? They have all the tools that, like, nothing prevents you from soldering at all, but I'm not the big fan of soldering, and this thing is really helpful. But again, altogether, around $15 at most, like, would get you started. If you're ready to wait for a couple of weeks, just order the same thing from AliExpress. It would be a few times less expensive. The code that runs here on this controller board is on the GitHub on the address you see there, along with wiring instruction and everything else. At this time, I'll happy to open the floor for questions.
Can you go back to the architecture diagram that you had?
Okay, the question is, can I go back to the architecture diagram?
So where does the MQTT broker fit?
That's here.
The hub? Okay.
Yeah, it's not what we at InterSystems do, because there are a whole bunch of implementations out there. That's just like not our business. If you're serious about that and going into the cloud, that would be your AWS IoT Hub, Google IoT Hub. If you're doing something local, start with Mosquito. Mosquito is open source, free, and you can start it with a few seconds and simple, like as YAM install or something like that.
Ravi from University of Miami. Pretty interesting, but curiosity from making it production ready in a sense. Like what? Most likely the scenario will be like, I have a patient at home, nothing to do with the connectivity here.
Yeah.
Like how do I connect my other there, like whether it's a Fitbit, whether it's like any other IoT enabled device. Typically you'll have a hub somewhere, either to your phone or somewhere where they're pushing the data.
Yes.
Like how would that work? Because from this standpoint, I'm not sure how we can make it. This is very interesting to learn, but like from a
I have extended version of IoT presentation where I go through all the communication scenarios, and depending on what kind of area you need to cover, you have an option of Bluetooth. Like there's version of Bluetooth that can work across, well, within the large building, if we're talking, say, a retirement home, right? You can put one Bluetooth gateway. Then you have LoRaWAN. LoRaWAN is, again, low bandwidth, low battery requirement protocol that can work for up to 10, 15 miles. Right, and that's, again, it's not licensed as long as you used one of the dedicated frequencies, right? The hub costs around $200, and the device, the controller, there's a version of this controller with LoRaWAN, besides Wi-Fi, LoRaWAN, cheap. It costs, I think, $15, right, to get the same data. And if you're really in the middle of the desert, there is a satellite communication. And satellite communication, again, it's surprisingly not that expensive. I think it's just few cents for a message. So if you send in data like few times a day, or in case something happens, it's not prohibitively expensive. The typical scenario, again, it's cell communication. There are a whole bunch of companies that would sell you SIM card that has nothing but data with very low bandwidth, but it's very cheap. It's exactly for the scenarios like this. Like if you need to get your heart rate every few minutes, right, it's perfect. It would cost you pennies a day just for bandwidth, right? And with 5G adoption, again, there would be more and more and higher and higher speed communication. And hardware for that, again, at AliExpress you can buy for under $10. The little extension to this controller where you can stack the SIM card in. It's surprisingly affordable, right? One of the demos I did is parking sensor, right? And parking sensor, if you build it like this, it can probably run up to a couple of weeks on the battery. Right? If you do it on industrial scale, you change the sensor and the sensor in my demo is something you would find in Roomba to avoid obstacles, right? The sensor that you would see in the parking lots that would display you the number of spaces left is using the same sensor as you have in your cell phone as a compass. Basically detects, do I have large metal thing on top of me or not? Right? And a whole bunch of people are quite quick and clever to hack it just by putting a little magnet on top. Like, oh, this stuff is reserved for me. Right? But industrial version of it costs around $100, uses LoRaWAN as your communication protocol, and battery lasts 8 years in Canadian winter. Right, so these kind of things are surprisingly affordable now, right? And you have to do a whole bunch of other things if you want to make it from this little prototype to production, right? It should be all secured, like you have to have keys provisioned and so on and so forth. If you going into FDA approval, good luck with that. Have to have very good investors, but it's all doable. Thank you.